In this video, we're going to be talking about partial fraction decompositions, and we're going to be giving examples. In particular, we're going to be talking about partial fraction decompositions that involve the denominator only having distinct linear factors. Okay, so let's go ahead and get started with this example. First step is going to be to factor out the denominator. So let's write this again with the factors. Let's see, how do I factor this? So to factor this, I'm going to have to think of two numbers. When you multiply them together, you get positive 6. You add them together, you get negative 5. So that'll be x minus 3, x minus 2. Right? If you add negative 3 and negative 2, you get negative 5. And then if you multiply them together, you get positive 6, okay? All right, so distinct linear factors, that means none of these factors are being repeated, right? This is a factor that's, of its own, and here's another one. So they're distinct. So like if you had x minus 3 and then it was squared or something, then it would be kind of being repeated. And so that would not fit under this category of being distinct. So in the next video we'll talk about, or in a video to come, we'll talk about that sort of situation. Okay? All right, so now that I have it written like this, I can write this, and so what I'm going to have is some unknown partial some unknown partial fraction. So a minus 3. So a over x plus x minus 3. And so that's unknown. And then b over x minus 2. Okay, so here's x minus 3, here's x minus 3, and then here's x minus 2, and here's x minus 2, okay? So I've broken it up into those two pieces, and then a and b are unknown, so I'm going to have to solve for a and b. That's kind of the objective now at this point, okay? So to do that, I'm going to write this. So to do that, first thing I'm going to do is I'm going to multiply both sides of the equation by x minus 3, x minus 2. Okay, so I'll have a here, x minus 3 plus b, x minus 2. So I'm going to multiply this by x minus 3, x minus 2. So I'm multiplying both sides of the equation by x minus 3, x minus 2. On the left-hand side, these two will cancel, and I'll be left with just x. Okay, on the right-hand side, when I distribute, I'll have a over x minus 3, and then that will be multiplied by x minus 3, x minus 2, plus b over x minus 2 times x minus 3, x minus 2. Okay, so this cancels and this cancels. So I'll be left with a times x minus 2 plus b times x minus 3. At this point, there are two ways I can take this. First I'll explain the easier way, and then I'll explain, another way. And so the first way I can take this, I can say, oh, well, if I plug in x equals 3, then I'll be able to solve for a, because this will cancel out, right? So the first way that I could do this is I could, take x equal to 3, and so if I were to do that, I would have 3 equals a times 3 minus 2 plus b times 0, right? So x is 3, so 3 minus 3 is 0, so that goes away. So now I have 3 equals a 3 minus 2 is 1, so that's basically just a. So a equals 3. and then to find b, I could plug in x equals 2. So then I'd have 2 equals a times 0 plus b, and then 2 minus 3, so b times negative 1 equals 2, so negative 2 equals b. Okay, so that got me results, right? I find what b is and what a is. the other way I could find what A and B are, so I'm going to explain both ways, is I could distribute, I could continue this work here, distribute the A and combine like terms. So I'll have AX minus A times 2 plus BX minus B times 3. And let's go ahead and combine like terms. So I'll have A plus B times X, right? That got rid of this term and that term. And then plus negative 2A minus or A2 B times 3. And that gets rid of those two terms. Okay, so now when I look over here, I see that on this side I have a leading coefficient of 1 in front of the x. Right, so A plus B obviously must equal 1. And then I have no other coefficient or on the left-hand side. So this 2 times A minus negative 2A minus 3B, this must equal 0, right? Because there's no constant out here, right? And this would be a constant. So we could set this up as a system of equations to solve. So we would have A plus B equals not 0 but 1, right? So this here would have to equal 1 because there's a 1 there. And then negative, I'm going to go rewrite that differently. So negative 2A minus 3B would have to equal 0, okay? And this is a system of linear equations. So I could solve this system by using maybe the elimination method. If I were to do that, I would multiply everything on the top by 2. So I'd have 2A plus 2B equals 2. And then I'd have negative 2A minus 3B equals 0. Okay, these get eliminated, and then I end up having negative 1B equals 2, and then B equals negative 2. Okay, and then if I were to back substitute, I could use the first equation, and so I could have A minus 2 equals 1, or A equals 3, or if you add 2 both sides. So A equals 3, B equals negative 2. Either way, you get the same answer, okay? So it doesn't matter if you want to use a system of linear equations or if you just want to, look at this and then think about what you need to plug in. Either way, you'll get the same answer. Okay, so in the end of the day, what is my final answer? I need to write, my whole goal is to decompose this into into its partial fractions. So I need to write my answer as, so A is 3, so I'm going to write it right here. So 3 divided by x minus 3 plus, and then B is 2, negative 2 actually, so instead of writing plus I should write minus 2 over x minus 2. Okay, and those are my partial fractions. So let's go ahead and do one more example. Alright, so in this example I have more than 2 factors on the bottom, so for each factor I need to break it out like this. So I have A x minus 1 and then plus B x plus 2 and then C x minus 3. Alright, and then I need to find each of these fractions. The first step is always going to be to cancel out what's on the bottom. So to do that, I'll multiply both sides by this x minus 1, x plus 2, x minus 3. Okay, so when I do that, on the left-hand side, everything on the bottom will cancel, and I'll just have that 30. And then on the right-hand side, I'll have A times, well, the x minus 1 will cancel, and I'll be left with x plus 2, x minus 3. So let's write that. X plus 2, x minus 3. And then B times, so the x plus 2 will cancel, so I'll have x minus 1 and x minus 3. X minus 1, x minus 3. Okay, and then plus C, and then the x minus 3 will cancel for that term, so I'll have x minus 1, x plus 2. Okay? Alright, Now, I'm going to go ahead and you can use system of linear equations, or you can just plug in certain things. I'm going to go ahead and plug in certain things to get my answers. So I'm going to plug in x equals 1 first, because that will cancel out this term and this term. Okay, so I'll be able to solve for a, right? Because there's x minus 1 and x minus 1. So I'm going to plug in x equals 1. So if I do that, I'll get 30 equals a times 1 plus 2, 1 minus 3. 30 equals a times 3, negative 2. 30 equals a times negative 6. Then I'll divide both sides by negative 6, and I'll get negative 5 equals a. Okay, great. So now there's 1, and now let's plug in, let's see, I want to solve for b next. So if I plug in x equals negative 2, then this one will cancel and that one will cancel. So let's go ahead and do that. Let's plug in x equals 2. Negative 2, actually. Negative 2. Right? Okay. And then I'll have 30 equals, so the first term will cancel, and then b times negative 2 minus 1, negative 2 minus 3, and then the third term will also cancel. So this would be b times negative 3 times negative 5. Okay, and that is b times 15, and divide both sides by 15, you get 2 equals b. Okay. Alright, lastly, let's solve for c. To solve for c, I'm going to plug in x equals 3. Plug in x equals 3. And that's because this one has x minus 3 and this one has x minus 3, so I'll be left with only that term. So then I'll have 30 equals c, 3 minus 1, 3 plus 2. Okay, 30 equals c, 3 minus 1 is 2, times 5. c times 10. Divide both sides by 10, you get 3 equals c. Alright, so now I can write my partial fraction decomposition. It will be, first I have negative 5, so that's a over x minus 1, and then plus 2 over x plus 2, and then plus 3 over x minus 3, and there you go, that's my answer.